Okay, let's look at the nth root test. Essentially, you have a series, and oh, I don't know which one will I do. Let's pick something that's relatively obvious. Yeah, something like this, 1 plus 4 over n to the power of 3n. Now, if you ever get a series where it's a bracket and it's raised to a power, and the power has to have an n in it, or an n squared typically. So 1 plus 4n to the power of 3n, 1 plus 4n over n, 3n squared. This thing here could be 1 plus n, it could be anything you like, but the essential, the thing that makes it an nth root test is that this power has at least an n in it. Now, in this case then, an would be that fella. And what the nth root test says is,
does this include
that you find
powers?
Yes, so it could be negative 3n, if that's what you mean, yes. So the limit as n tends to infinity, the nth root, that's why I like that name, of an. Technically the absolute value of it, but it's probably going to always be positive, so it's not a big deal. It will equal something L. If L is greater than 1, the series diverges. If L is less than 1, the series converges. Isn't that exactly the same rule or test that the ratio test does, right? Bigger than 1, you diverge. If the limit is less than 1, you converge. And what happens, or what do you think is going to happen when the limit is 1?
Inconclusive.
Inconclusive. So it looks like, I'm doing a quick scan here. It looks like there are 3 of these questions. So the questions are questions, check it again, are questions 10, question 11, and question 12. And so what we need to do here is we basically need to find the nth root of this guy. So in this particular example then, the limit as n tends to infinity of the nth root of this guy becomes the limit as n tends to infinity. So now we need to do some algebra here. What do you think the nth root of something raised to the power of 3n does? How do you think those two things interact with each other? And in particular, what power of that do we end up with?
Cubed.
Agreed? Now, that guy is actually easy to do. Can't I just brute force this guy? So 1 plus 4 over infinity cubed, 1 plus 0 cubed, 1. It is an answer, and that's the answer, is inconclusive. And you get 3 choices typically. The series is convergent, the series is divergent, the test is inconclusive. So in the way that these questions are set up, that's kind of how it's going to look, right? So far, so good. So I want to show you some algebra things that are likely to happen here. Sometimes you're going to end up with 7 and some stuff. The nth root of 7 and some stuff. In particular, that's what the 7 will get you. It will get you 7 to the power of 1 over n, right? Now, if you brute force that, that becomes 7 to the power of 1 over infinity. That becomes 7 to the power of 0. That becomes, oops, that becomes 1. So in this question that I've just done, this one here, imagine they put a 4 there. Do you see how I cope with the 4? I just call it 4 to the power of 1 over n. Right, so if they stick a 3, a 4, a 5, anything like that. I haven't seen a situation where it doesn't end up being just a 1 at the end, which means it doesn't affect anything. But that's how you take care of it. And this is getting really, really messy. Suppose that we had a -4 or some negative going on. Because someone says, what about negatives? Not negative powers, but negatives here. Well, because this is an absolute value, won't that annihilate all the -1 to n's and -5 this and -7 that, right? Any normal negative, right, a negative here will disappear because its absolute value is positive. Even -1 to the n will also disappear. So that's how you'll take care of, you know, -1 to the n 4 times the real thing. So pretty much this is where the fun starts. And there's one last, well, sorry, 2 last things that could happen. You can end up with that. I mean, that could happen with the nth root of n, 1 plus 1 over n squared, you know, something like that. Now that guy becomes n to the 1 over n. What's the limit as n tends to infinity of n to the 1 over n? And I hope, I'm crossing my fingers, I actually told you this. If not, I'm about to tell you again. It's magic. You just trust me because I tell you it's 1. Did I tell you it? I hope I did. Yeah, so that's that guy. Now, that means that there's one last guy, and I definitely know then I told you this guy. Sometimes you can end up with that, and you might think, well, there's an n there. I'll show you how that could happen. And put a b there, right? Doesn't the limit of that end up being e to the a b? And I'm pretty sure I even proved it to you, although you don't need to know how to prove it, right? So how could that happen? Well, can you imagine a series where you had 1 plus 3 over n and 5n squared? When you take the nth root, all you kill off is one of the n's. So that would be a situation where this could happen. Okay. So let's do a couple more examples of them. Hopefully I can find some examples where that happens. This one is question 12, or at least like it. Now, in this question, n is going to be this guy. Oh, do you notice that this limit starts at 2 instead of 1? You know, sometimes they start at 3 or 4. Does that have any effect on the answer to, is this convergent, divergent, or inconclusive? Does that matter in any real way? No. Sometimes it's there because maybe at 1 a bad thing happens. In this case here, at 0 a bad thing happens. But you know, that's, you know, or maybe they just wanted to do it. There's no need for them not to. So let's do the test then. It's going to be absolute value of the nth root of an. It's going to be the limit as n tends to infinity of the nth root of all this, which becomes the limit as n tends to infinity. The phi becomes 1 over n, and the 1 plus 1 over n to the n squared becomes an n. Right, you cancel out one of the n's, you've still got an n left over. Right, and we're doing this as magic. What did I say 5 to the 1 over n gets you?
1.
As n goes to infinity. Say again?
1.
1, yeah. And what about the magic? What does that guy get you?
E.
Right, e to the 1, which is e. Which means that the limit here is e. So do you see from here to here, you just use magic. You just say, I know what they are because somebody told me that's what they are, or it was proved to me, whatever reason. You now get it. By the way, isn't e bigger than 1? It's 2.7128 roughly. So that means this one diverges. You agree? Okay. Let's do sigma n equals 2 to infinity, negative 4 over n squared plus 1 to the 3n. So I'm going to do the limit as n tends to infinity of the nth root of that guy. Technically, the absolute value of it. What do you think is going to happen with that negative that's next to the 4, the negative 4 guy?
Goes away.
Am I going to have, it goes away, right? So it's a whole brackets to the 3 to the n, so don't you basically kill out, or kill off, whatever the word you want to use, that guy. Now, I could FOIL that out and divide top and bottom by whatever I felt like and eventually get the answer and the limit ends up being 0. Right. Or I could do this. Couldn't I find the limit as n tends to infinity of this guy and then cube the answer? Remember that trick that you can do the limit of a calculation or the calculation of a limit, especially if that makes life really hard. Right. Looking at this guy, what's the limit of this going to be? Because I want to speed things up.
0.
0. Couldn't you do L'Hopital or divide top and bottom by n squared, whatever technique you like? You're like, would you be happy that this is 0? Right. So this is 0 cubed then, which is still 0, which is less than 1. So now we can look at converges. Are we comfortable with the nth root test now? You only get 2 or 3 shots at it. Right. So let's look at this fella. Absolute and conditional convergence. A series, sigma an, n equals 1 to infinity, is absolutely convergent if this series is convergent. In this form here, couldn't this be, negative 1 to the n, 1 over n cubed? It could have pluses and negatives in it, right? When I do this, doesn't that make everybody positive? So basically, you take the series and you destroy all the negatives in it. And that new series, you test it. If that new series is convergent, then so is this one. Now, a series, n equals 1 to infinity an, is conditionally convergent if, I guess I should say that, if this fella is divergent. So you've got a series that converges, negative 1 to the n, 1 over n is a good example. But when you make everybody positive, it's divergent. If you have a series that's okay the way it's written, but the minute you turn everybody to a positive, that new series is a divergent one, then we call the original one conditionally convergent. An absolutely convergent one, the series converges and you make everybody positive, and guess what? It's still converging. Then if that happens, we say that it is absolutely convergent. Now, they have a third one, which is just divergent, but divergent is still divergent, right? If the thing adds up to infinity, the original, it's divergent. So let me show you one of each, a very simple one. A lot of these questions get generated by alternating series. A lot of these is absolutely or conditional. You recognize that as an alternating series. Okay? In fact, we probably did that one. I'm going to skip a whole load of stuff here, but can you trust me that I can prove that that's decreasing and its limit is 0? So it converges. Well, we take that as a granted that that guy does converge, right? You probably, if you go back in your notes, you'll actually see me doing it, right? Let's just assume that is true. Now, what would the other guy look like? Well, that's the guy where everybody's now positive. Essentially, just make that go away. Now, what do you know about that one? Because we've also done him. He even has a name, doesn't he?
Harmonic.
Right, and doesn't it diverge? Right? We can prove it, but doesn't it diverge? It's a P series, whatever way you do it, diverges. What name then do we give to the original series? That was the original. It converges, but when you make everybody positive, it diverges. What kind of name do we give to that series? Conditional, absolute. Which one does it get?
Conditional.
Condition. And that's the answer, condition. So it's a conditional series. Let's show you a different one. Keeping it simple. That way I can skip some corners and then we'll do homework questions. I don't know if you recognize that guy, but it's an alternating series. Does it take much convincing that I could prove to you that it's decreasing and its limit 0, so it converges? Would you be pretty comfortable that it's true? Because it is. Now, if I make everybody positive, do you recognize that series? It's a whole family of them. You remember what the name for all the guys that look like that?
Geometric.
No, not that one.
Harmonic.
It's got a letter
P
in the
series?
alphabet. P series. It's called the P series. Now, in this case here, the P value is 2. And because it's greater than 1, that makes it converge. So that series, the original, converges. When you make everybody positive, it still converges. When that happens, the original is called absolutely convergent. Now, what about a series that diverges, right? So if the original diverges, the answer is it diverges. You don't do any more. You're not going to fix it by making everybody positive. It's going to diverge every time. And so they're probably the simplest ones to do. So let's physically do one rather than just do a kind of cut corners version. So I should be able to find one around here somewhere if I try hard enough. It's pretty. Let's do this one. Now, in the homework, it just has 3 circles. You absolute convergent, conditionally convergent, or it just diverges. So our job is to figure out which one of those 3 it is. So let me look at this guy. Would you agree this is an alternating series, which most of these questions are going to be, right? Now, for an alternating series, I need to prove that the limit is n tends to 1 of this guy is 0. Well, I don't need to do a lot of hard work here. Can't I just brute force it? So, yep, it is definitely 0. And I also have to prove it's decreasing, which means I have to show that this fella is a negative derivative for values of x greater than or equal to technically 0 or 1, but you know, pick a big number like 10 just to feel safe. Would there be a better way to write this guy if I wanted to find its derivative? Would there be another way?
Pull it up to the top with a negative exponent.
Now, if I do it that way, it becomes a chain rule. If I left it this way, couldn't I get the answer by a quotient rule? So it's not like I couldn't do it. It's just, I think this version is a little bit quicker. So multiply by the power and reduce the power by 1 times the derivative of 4x plus 1 is 4. Then make it look pretty. Style points. Which, by the way, is why some of you missed some points in your homework, in your test. You didn't prove the decreasing part. So, would you agree the top is negative all the time? Would you agree that 4x plus 1 squared is positive all the time? So the answer is negative, and that makes it decreasing. So I have shown that this series, this one here, converges. Now I'm going to check what does it look like when everybody is positive, which essentially means we're about the negative 1 to the n. Now this is a new series, looks similar, but it's definitely new. And the way we're going to approach this one depends on your choices. Any suggestions for how to prove that that converges or diverges? How to test it?
Just do P series.
Comparison test to a P series, I agree. If that's what you mean, yes. Is that what you mean?
I was just saying P series, but I'm looking at my notes.
Yeah, it should be a comparison to a series. Do you know I could also do it with an integral test if you wanted to? I'm going to do a limit comparison test. And I'm going to do it to a P series. Okay, well, let's see who this fella looks like. Doesn't he behave like that guy, or if you want to, doesn't he behave like that guy? Remember we did the most important guy in the top, in this case it's 1, most important guy in the bottom is n. So this guy is going to be my bn, my comparison guy, and this is the original. In the limit comparison test, you take the limit of that guy. In this case, it's going to be the limit as n tends to infinity of the original all over this guy. Algebraically, that's really ugly. So it's going to be this guy times that guy. And you might not need every line here. It now becomes this guy. Now, I could have compared it to a photo. Oh, by the way, what's a 1 over n? It's a p-series, isn't it? And it's a p-series where p equals 1, so doesn't that make it divergent? Remember, if p is less than or equal to 1, it's divergent, right? So if it was p equals 2, it would converge, for instance. Right, back to this fella. I could do L'Hopital on that. I could divide top and bottom by n. What would the limit be? You probably should be able to just look at that and tell me what the fraction is. What would this get you?
1/4.
Right. Now, according to the limit comparison test, if the limit L is a number, right, that's any number as long as it's not infinity, right? Remember that little exception. Then doesn't it behave the same way as this does? Oh, wait a minute. That means that this diverges then, right? So I have a series that in its untouched form converges, but when we made everybody positive, it diverges. And we have a special name for series that have this property, that the original converges, but when you make everybody positive, it diverges. Just to repeat the name, the more times we repeat it, the more it's likely to stick. What do we call it when that happens?
Conditionally convergent.
Conditionally convergent. So the 3 choices that you had up here, you would be putting a dot there. Do not do this. Please don't do this. I'll do the first one. It didn't work. I'll do the second one. It did work. I've just spent 10 seconds and done a homework question. You're only getting 3 choices, so you're going to be able to guess the right choice. How to prove it is going to be the killer. And you can imagine you get a test in this in the final exam. If all I see is a dot here, and I don't see any of this, you ain't getting any points, because all that means is you guessed. And you don't get, you don't get points for guessing. This is not the way these things work. You see how the process of testing for absolute or conditional works. Now I'm going to give you a silly question, and it's a trick question. Absolute convergent, conditionally convergent, or divergent? What's the answer to that one? The reason it's a trick question is you don't need to do any working to tell me the answer.
Conditionally convergent.
Think again.
Divergent.
Yes. Can you see it getting just bigger and bigger and bigger, jumping, adding a big number, then taking away an even bigger number, but adding even a huger number? I'm just think about it. What does the limit of n tends to infinity of n cubed get you? right? And they're going to diverge just on its own. So that would be the exception to a homework question where you needed to do a whole load of work. If somebody gave me a version of this, I would just say divergent, not even think about it. Right, let's see if we can find another one. Oh, this one's sneaky. This one randomly has negative values in it. So it doesn't have the typical negative 1 over n, 9 to the n thing, right? So this one is going to be a little bit different than typical. In fact, I would probably describe this as a one-off question. So here goes my argument. This is the untouched version. Although I do not know an awful lot about the sign of n, don't I know one thing about it? Isn't it never bigger than 1? So this guy behaves like that guy. So I'm not going to do a limit comparison test. I'm just going to do a comparison test. And in a comparison test, you just say, if this behaves like that, since this, oh, by the way, I have to find out what this does before I tell you what the comparison test says. What is one, imagine you put sigmas through, right? What's sigma 1 over n? What kind of guy is that? Because somebody earlier on mentioned the name, and this time this is the guy.
Geometric.
It is. And what is the R value for this fella without going into too much hard work?
One-ninth.
1/9. And isn't the absolute value of that less than 1, so doesn't it converge? So by the comparison test, the original, that's this guy, converges. Now, if you make everybody positive, I'm going to do a comparison test. And guess who I'm going to do a comparison test to? So essentially, doesn't this behave the same way in both situations? So it's absolutely convergent. I'm not even sure why I'm writing that because it's the same sentence up there. And it converges before, it converges after. So use that technique in this situation here when there's a sign in the top. I would also use this technique if they did that guy. I would also use this technique if they did that guy. I would also use this technique if they used that guy. So if there's something funny on the top, and funny means sine or cosine, or things like e to the 1 over n or e to the 1 over n cubed, you can basically just do a comparison test. You could almost do it in your head. Do you know that e to the 1 over n is pretty much going to be 1 for most of its life? After about n equals 5, it's dead close to 1. So it would behave like that. And this guy would behave like that.
So for the signs, you wouldn't have to do a sandwich, compare it to both 1 over 9 to the n and negative 1 over 9 to the n?
Well, the way I can get away with that is because when I stick an absolute value around it, don't both of them become 1 over 9 to the n?
Yeah, so that's for the second one. I'm talking about for the first one.
Or the say for the first one,
Because it would be the same thing.
I guess so, but it'd be the same thing. Yeah, if
Yeah.
you want to, yeah, and I guess we should want to be precise. Yeah, and it's going to be the same thing in any situation like that, because +1 and -1 doesn't really. If a thing's infinite, sticking a minus in front of it's not going to help any. And if the thing converges, sticking a minus in front of it just makes it converge to the negative thing, right? The negative total. So it works in that sense. Right, this is another one like question 6. And this question is a little unfair, and it's not clear why it's unfair, but let me tell you why. Shouldn't we be looking at, does this converge untouched? Then shouldn't we be looking at it, what happens when everybody is positive? The problem is, isn't this already everybody is positive? Would you agree k 3/4 to the power of k is always positive terms? So all I need to do is test this guy. Right? I don't need to test the untouched version and then the version which is a all positives. If this question had been -1 to the k 3/4 k, right? Something like that. Then wouldn't I be testing that as an alternating series, and then I would test everybody positive after that, right? But in this question, since the original term only has positives, can't you just test the original? And if it's convergent, it's absolutely convergent. So here goes. I am only going to test this fella. Now we have to figure out what test. I'll tell you, it's not a comparison or limit comparison test. And I know that 3/4 to the k is very tempting. Right?
Geometric series test.
You could try a geometric series, but won't the k kill it? Agreed? What test have I not mentioned yet? Well,
Nth
I've
root.
not mentioned. Say again?
Nth root.
I've not done the nth root test, and it would work. And I've not mentioned the ratio test, and it would work. Now, you know the work involved in doing a ratio test. Hopefully you can guess the work involved in an nth root test. Which one of those two tests do you think is just going to be less work for me? And that's the one I would pick, because I like less work.
Nth root.
I would agree on nth root. So let's do it. Let's find the limit. I guess I'll have to call it k tends to infinity of the kth root of this guy. Well, that's going to be the limit as k tends to infinity of that guy, right? And, oh, well, you can't get much nicer than 3/4, right? We've already done this guy. What does k to the power of 1 over k get you when k goes infinite?
1.
What's that? You might have said that and I spoke over you.
1.
1. So isn't the answer 3/4? And according to the nth root test, if your limit is less than 1, what do you have? Converge or diverge?
Diverge.
Yep. So this fella is not just convergent because they're all positive. It's absolutely convergent, which is the choice that you had to pick. Are we okay with the conclusion that we came up with here? Now, you could have done the ratio test in that and it would have worked. It would have told you the correct answer. Right, so this is the last question, which is perfect timing because it's going to be the last question for today. So if you all say hi while I'm setting this up. This question has nothing to do with absolute convergence or conditional convergence. It just says, for what values of x does this series converge? Now, I want you to think of x as being a number, 4 to the power of x, or a fraction, a half to the power of x, right? It's a fixed value. The way I'm going to solve this is I'm going to use the ratio test. Why am I not going to do the nth root test in this particular question?
The factorial?
Yeah, nobody in the world is going to be able to figure out what the nth root of n factorial is. In fact, I'm not even quite sure how you write it, right? So, but we know how to do with factorials in the ratio test. In fact, if you ever see a factorial, don't you always go ratio test? I mean, it's kind of the go-to sign that you look for. So that's going to be the limit as n tends to infinity. N plus 1 gets me that guy. Can we do the turn me upside down thing so I can save a whole line of work in? Are you happy with the en being turned upside down and now is that guy? I'm going to stick the absolute value around it because x could be negative, I guess. And if we cancel, I get x. And if we cancel these guys, I get n plus 1. Now, let's do a brute force on this. If x is just any old number, right? It could be minus 42, it could be a half, it could be 70 or whatever. Isn't that number over infinity going to get me 0? Would you agree? Now, it's less than 1. So by the ratio test, it converges. And doesn't it converge no matter what x is? So I have a whole load of choices. And one of the choices was for all values of x. So that would be the answer. And then there's a part B where you can choose what it says. And that is a perfect time for us to finish. So when I see you tomorrow, we'll spend, I don't know, about 15 minutes looking at the section that we're not going to do for homework, which is pick the right test. So what you're going to get is a whole load of questions. Here's a series. What test would you use? Actually, today, haven't we had to just make that decision sometimes? Oh, are we going to do a comparison test? Are we going to do a ratio test or an nth root test? Or what was the other one? An alternating series test, right? We already had that decision to make. So you've kind of done practice at that. So it's not like I'm skipping something that, you know, you don't already know or should be getting used to doing anyway. We are good to go. I'll see you all tomorrow. Usually you want to hang about because you want to ask homework questions or ask what did you do wrong in your test, and how did you do it wrong, I'll hang about for you.
With regards to the test, will you be telling us
Yes.
where we got wrong on that, or do we just get the score and that's it?
Well, that's it. You just get the score, but you're going to look at your score and you're going to say, I don't know why I got question 4 wrong, because WebAssign will at least tell you it's wrong. And if you can't, you could go over it and you think, I don't know where I went wrong. This is the place you're going to find out. So I will go over that question for you.
Okay, I need to look through WebAssign then and see what
yeah,
I did wrong.
Okay, while you're doing that, the reason I cannot do a solution to that is that the WebAssign questions are firstly randomized, so everybody gets a different version of the same question. Yeah, you get 4x, he gets 10x, right? Secondly, they're pooled, so for any given question, there was 3 different versions of that question. So if I wanted to make a solution, I would actually have to make a solution for every single person, because you all got a slightly different test. And it's just not really practical for me. So hopefully the ones you got right, you don't really care about, because you know you did them right. And you're probably only interested in the ones you got wrong. So this is what we can do right now. Sam, you probably got the one to start the ball rolling. So what you got?
I cannot see my test, so I can't tell what I got wrong.
I can't either.
Have I locked it out? Okay, you give me 2 minutes to go in and fix that problem, because it's probably because I put the only see it until the end of the test restriction, but I can withdraw that now. Eventually. Close that off. Do that. Hit that. Hit that. Oh, darn it in space. It's just give me a few more minutes. It's just being awkward because it can be. I'm going to have to go back in from scratch because I think I timed out. Come on. Okay, we're slowly getting there. Got that. Somewhere in here there's a test. Yes, reschedule assignment. Do past. Where are you? Test 1. Change that guy to 3. Okay, it says it did it. Hit save. Okay, do you want to refresh your thing and see if it's done what I think I made it do?
I can see it now, I think.
Okay, I'm just going to do one more if I can get into it. One more change that might help you check your thing. Edit, there we go. Edit settings. Right, it's good. All right. Now, the settings that I believe I've got, I can't guarantee that because I'm not 100% sure. You should be able to see what you typed in, but it might also tell you what the correct answer is and some other things. Does it give you that information as well?
I don't see the correct answer, no.
Do you just see it's right or wrong, or only what your answer is?
I see that it's right or wrong.
Okay, but you don't have anything else. Let me see what else I need.
If you mean like it shows what I did wrong, it does show me what I did wrong, but I don't see the right answer.
Okay.
I clicked view key and other stuff popped up, and I think it shows us the answer.
Okay, so view key. Does it also have a box that has something like solution? And if you hit in that, it will give you
Yeah.
a solution. Do you see that?
Well, no, when I clicked view key, it shows the solution next to my wrong answer and then how to solve it generally, I think.
Right. So it doesn't specifically use your numbers, but the process that you would use to solve it. Are you seeing that as well, Sam?
It looks like it does use my numbers, I think. Yeah, it does.
Okay, so that's backup, but you know that isn't always enough. So give me your question, Sam, and we can go over it.
So number 2.
Okay. And is it short enough to just read it out to me? Oh, it's darn spicing, getting annoyed with this machine. Just kicked me back out again. Can you read the question to me? Otherwise, I'm going to have to go back in and do this from scratch, which is a real pain in the butt.
Yeah, so
Getting annoyed
it's
at this.
the sigma of 6 over pi to the n power.
Right, and there'll be some like n equals 1 to infinity or 0 to infinity at the side, I'm assuming.
N equals. Yes, just like that.
Right, 1 to infinity. Okay. Do you recognize that as a geometric series? That may be your first break. But if you write down the first few terms, the first term looks like that. The second term looks like that. Third term looks like that, and then it just keeps going forever. That guy there is called A, it's the first term. And you get the common ratio by taking this guy and dividing it by that. Or 1 over pi is what you eventually get.
Yeah. Okay, so it looks like that's what I...
So, okay. So it converges because the absolute value of r is 1 over pi, and 1 over pi is less than 1. It's about 0.3 very roughly.
Yeah,
so that
I
makes
got...
it converge. So let's see what the sum is. A over 1 minus r. A is that guy over 1 minus r, which is that guy. And now I'm going to make it look pretty by multiplying by a special version of 1 called pi over pi. And this fella becomes 6, and this fella becomes pi, and this fella becomes 1, and now you have a nice answer.
Okay. I see where I got it wrong.
Was this went wrong, or you didn't make it pretty?
I went wrong with calculating the s. I got a 6 pi somehow. So that simple mistake.
Okay.
Okay.
Easy done. Not that I have ever made a mistake. I don't understand how students can, because I never make mistakes any time.
Yeah.
Right, Douglas? Yeah. Okay, just checking. Okay, you got another? Maybe you should balance it. Ian, maybe we'll do you and then we'll do Douglas. Unless Douglas is just watching because he likes to see stuff. Right. Ian, you got a question?
Okay, so one thing real fast and then my question. So I got half of 2 correct. I had it convergent, but I typed in a rounded decimal answer because I didn't figure out the fractional form, even though it's technically the same. So
yeah, you would have lost some points, but not all the points because of that. So how many points did you? Well, you got to remember that when you look at your score on WebAssign, it's not the score that I gave you, because I gave extra points. So I would have given you, I think WebAssign would have probably, you'd lost half the points gone to it, because it would say, write wrong. That's all it does. But I would have given you back a fair number of those. So
I think you
that
did
you
give
know
me
what your
back
mistake
some,
is,
yeah.
and that's it.
And then
So that's what happened there. You still wouldn't get all the points because it needs to be an exact value unless the question specifically says to do decimal places. Then you can do decimals.
okay.
All right, and what's your question?
It looks like I got number 4 wrong, but it gives me like the entire process on how to do it. So I don't think I'll need your help with
You need
it.
me to go over it?
I don't think
Okay,
so.
that's fine.
Thank you though.
I mean, you can always do it again tomorrow if after looking over it still doesn't, click. Right.
All right.
Is there any other homework questions that you want to do apart from that one then? Any test questions, I should say.
I
Or
think I'm
homework, that
good. I'm
works
gonna
too.
go through what the website gives me, and then I'll come back tomorrow after class if I need any help.
Sounds like a plan, eh?
Thank you.
Okay, Douglas, so you're welcome. Douglas, you got anything?
Yeah, it's just a quick question. It's
Sure.
not about the test. It's about my attendance. It said that
Right.
one of the days on the very first week said that I was missing, or I was
Right,
absent.
and you weren't. Right. We can fix that. The highs
know,
don't
like-
work perfectly correct, and sometimes I miss your name and I'm scrolling through my attendance, so it's not a biggie. I can fix that as we speak. I'm just loading it up
Okay.
right now, and let's put this one in. Third from the bottom. Okay, that's an easy fix. We're done. Right, you got anything
Great,
else?
Thank you. No, I was just listening.
Okay, that's fine. Have you got any more questions, Sam?
Yes, I do. So I've got
Okay, what's the next
3
one?
more. So
okay.
Number 3, I can tell you what it is real quick. So it's
Go for
sigma. Sigma from n equals 1 to infinity of 9 all over n times n plus 3 with the n plus 3 in brackets.
All right, so let's return to this one. You have to recognize what you're doing with your, do you recognize this as partial fractions?
Yes.
Good, so let's focus on that. Now I know it's going to be that guy. I could probably do the quick way is the old cover up method. So cover that up and put in 0. And there's the other one.
Yep.
So I'm assuming that you did that part right. Okay.
Yes.
So what we're now going to do is essentially write down lots and lots of terms until we feel we know who's going to be left alive, and then we can work from there. So if I plug in 1, it's 3 over 1, take away 3 over 4. Then you plug in 2, then you plug in 3, then you plug in 4, and then you plug in 5. I think I've got enough here. Dot, 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 dot. Can you see that it takes a while, but once you get to here, that guy will cancel.
Yes.
And then this guy will cancel.
Okay.
Now, as you get to the end, the last one, if you stopped, whoops, that's an N. The last one that you would finish at is randomly at N. But the one before that, and the one before that, would look like this. Now, the reason why I'm picking 3 of these guys is, can you trust me that that one would get killed off there, right? Is because I know that there are 3 terms going to be left alive at the beginning. And that tells me that these 3 guys will be left at the end. There's a kind of balance, right? If 3 are on this side, then 3 will be left on this side because they're all going to cancel like this direction. So this entire mess, this thing here, I'm going to have to move over here now. Is going to be made up of a 3 over 2, a 3 over 3, minus this term, and this term, and lastly this term. And that's what I would get if I just randomly stopped at some place called n. And what we now do is we say, well, what would happen if n became infinite? Well, if n became infinite of all this, okay, you'd get this fella, and this fella. But wouldn't that be essentially 0, 0, and some more zeros? That's what it converges to.
Yeah, and that's where I got it
which
wrong.
is
I forgot to
5.5, which 11 halves.
Yeah, I forgot to bring over the 3 over 3, so I just skipped over that. So I got
Oh, you
9.
you missed that term.
Yes,
You thought they cancelled just 2 of them.
I didn't even cancel it. I just forgot to bring it over. So
Oh God, that's just. You're getting old. You're getting worse than me. But that's an easy fix again, isn't it? Because it's not that you had a major problem. It was just a little mistake. Okay, who's next?
Number 6. Pull that. Number 6. Okay, so it's sigma as n equals 1 to infinity of -1 to the power of n plus 1 all over 3n to the 5th power.
3n? We're 5 here?
Yes.
Okay. Do you recognize what series is this, and so what test I'm going to use?
This is the alternating series.
You got it. So I'm going to find the limit as n tends to infinity of this guy, which you can simply do with brute force, so it's 0.
Mhm.
The f of x function is going to be this guy, which I'm going to rewrite like that. The derivative of this is multiplied by the power and divide, and reduce the power by 1, and then make it look pretty. And then see whether or not this derivative is in fact going to be negative. Well, -5 is negative, and won't 3x to the 6 always be positive? And that combination is negative, so I know that this is decreasing.
Yes.
And so we have a converger. So what went wrong? If anything, I'm not sure now.
Oh, and then the next.
So that part you were fine with. So what was the next part?
Yes. So then it says, determine how many terms we need to add in order to find the sum with an error less than 0.00005. So 4 zeros and then a 5 behind the decimal place.
Okay. So we know from the alternating series test that an plus 1 is the error. And an plus 1, we don't care about the sign, is going to be basically that guy. And we're trying to find out what value of n makes that guy. And it's probably the easiest way is just trial and error. In other words, you keep picking n's until you get one that works. You want to give me a guess? It's not normally going to be that big a number. So just start the ball rolling. Give me a guess.
5.
5. So 3 over a bracket. 3 times brackets. 5 plus 1. Close the brackets. Raise to the power of 5. Close the brackets. And I get 4 with 5 zeros. Which is 0.1, 2, 3, 4. 4. Looks like you got the answer on your first guess.
Wait, did you put 6 in the calculator or 5?
I put 5.
Wow. Okay.
Here.
Well, I don't know what I did during the test, but that is not.
What number did you think it was?
I thought it was
4
8.
or 6 would be. Oh, that's not even close.
Yeah, no, and I
don't know. Maybe you forgot. Maybe you forgot the 3.
I think I just got confused with how to find the error, and then I went some weird direction with it.
Right. So the way you find the error is you find what an plus 1 would be. You make it equal the error, and then, unless it's a very simple question, you trial and error on the n value until you get an error that looks pretty much that way.
Okay. Is it possible that there would be more than one? That is.
Well, it might be in the boundary. In other words, n equals 6 might give me an error a little bit bigger, or a little bit better, not bigger. So I could try that, see what I get. And I get an error of 0.00002, but that's good enough. I guess I could try 4. Maybe it might make it, but I doubt it. And in 4, I get 0.1231. Yep.
Okay.
There is only one correct answer, but I'm just checking in case there was 2 answers that were very close to each other and one of them was better than the other. But that's the best you're going to get. We're looking for that error. And would you agree that that one's just a little bit more accurate, but that's okay. I'm pretty sure if you look at 4, can you see 4 is too much, too big?
Mm-hmm.
The error is too big. And this one here, it's really nice and accurate, but it's actually too small. It doesn't need to be that small.
Okay. Cool.
Okay. What's your next question?
Okay, so there's one more. So it's number 7. Where did I? Okay. So this is so sigma as n equals 1 to infinity of -1 to the n minus 1 power times n to the power of 9 to the power of n. Sorry, not n, 9 to the power of n. All over 4n, 4 to the power of n times n cubed.
Times n cubed. So I can stick it there, right?
Yes. Sorry,
Okay.
I was.
No, that's fine. Okay, we got to figure out a test.
So it looks like I used the ratio test.
Agreed.
Yeah.
Now, if you do the ratio test, then let's see where that goes. Technically speaking, I should be writing these guys in, but in the ratio test, don't these just disappear to 1 because of the absolute value thing, right? So just to make my life easier, n plus 1 n plus 1 cubed, 4 to the n plus 1, turn the guy upside down, n cubed, 4 to the n, 9 to the n, right? And I guess I don't
Yes.
really need all those absolute values. Okay, there's a lot happening here. That guy cancels with that and leaves a 9 on the top. This guy cancels with that and leaves a 4 on the bottom. I have an n cubed and an n plus 1 cubed, which I'm now going to multiply out. And that's where we are right now.
All
I
of
can
that-
find
Oh yeah, sorry.
I can find the limit of this ratio. Would you agree divide top and bottom by n cubed or L'Hopital? God, you'd have to do L'Hopital about 3 times, but eventually, won't you get 1?
Yeah.
Would you agree this would be 1, right? So what's the answer? The answer is 9/4. But that's bigger than 1. And according to the ratio test, if the limit is bigger than 1, what's your conclusion?
Diverges.
And that should have been the answer.